Hi, everyone. Welcome to Waste 360's Nothing Wasted podcast. On every episode, we invite the most interesting people in waste, recycling, and organics to sit down with us and chat candidly about their thoughts, their work, this unique industry, and so much more. So thanks for listening and enjoy this episode.
Good morning, everyone. Great to see everybody. Thanks for coming to this presentation with our panelists. The presentation is for waste conversion technologies, fantasy or reality. It's a good question. We're going to hear from some great panelists today. My name is Chris Hahn. I'm the CEO of MachineX Technologies. We're a manufacturer of equipment that can be pre-processing or separation equipment. And I'll let each of the gentlemen do their own bios right quick, just introduce themselves, and we'll jump straight into the presentation. I think you've got mics over there if you want to do it from there.
Good morning. I'm Steve Simmons with the consulting firm Gershman, Berkner & Bratton, or GBB. I'm the president of the company, and I'll be here today talking about a project we have in Kent County, Michigan. I'm an engineer, technology kind of nerd from a long time in this industry, but I'll have more on my presentation later.
My name is Tex Roberts. I'm with West Coast Energy. I'll be talking about waste conversion technologies that we're working on and implementing right now in California.
Bill Cooper with Cyclex International, which is a subsidiary of Agilex Corp. So we'll be talking about conversion technologies for plastics, pyrolysis, as well as on the Cyclex side, aggregating that plastic so we can supply both mechanical as well as advanced recycling.
Sean Gazelle, I'm with Waste2H, Vice President of Business Development. We have a technology that converts waste to hydrogen through a gasification process that I'll be sharing with you today.
Christer Henriksson, President of Juno, and I've been in recycling for the last 20-25 years. Love to talk about recycling, and here today to talk about our new technology called Juno that can divert recycle up to about 90% of what goes to landfills.
Great, thanks, guys. That being said, we'll start with Juno.
Great, welcome and thank you. As I said earlier, Christer Henriksson here to talk about my favorite topic, recycling. So, as you probably know, there's 8 billion people on our planet, and we are generating about 2 billion tons per year of waste, and most of that waste ends up in landfills. And what's frightening is that if you take a closer look at that waste, a lot of it is recoverable. And so, for example, paper fiber, plastics, metals, and food are materials that we should be recovering. So to me, we are in a bit of a waste crisis, and it's not getting better, it's getting worse. And as you think about the next 30 years, we're anticipating another 1.5 billion tons per year of waste coming online. So we need new technologies from a lot of companies, and that's why we are here to talk about Juno. So Juno is owned by Georgia-Pacific. It's a large consumer products company. We make anything from toilet paper, tissue, napkins, paper towels, to building and packaging products. And we are a very fiber-centric company. And we do a lot of recycling. We collect and consume about 2 million tons per year of waste papers, such like office papers, OCC, you name it. And this is how we got started thinking about a technology that could pull fiber out of landfills. And we came up with the technology, and then we realized that it can do so much more. So we developed it to also include for metals, plastics, and food. So we have built the plant in Toledo, Oregon, on the West Coast, and it's located right next to one of our flagship containerboard mills. And on the next slide, I'm going to take you through a video that shows how the process works, and I'm going to try to keep up with the video here. So this is what the plant looks like. We started up 12 months ago. and we've been running 24/7 around the clock for the last 6 months. We bring in unsorted residential commercial waste to a local transfer station and in Toledo. And we're collecting waste from all of these surrounding cities around Toledo. The first step is a pre-shredding step where we reduce the size of the waste to a specific size fraction. We then bale and wrap the material, and the wrapping process allows us to store the waste outside right next to our Juno plant. So we feed the Juno plant, and our first step is an autoclave, is a rotating autoclave that we call JunoClave, and we pressurize and heat it up using steam. And in the JunoClave, we then cook the waste materials, essentially sanitizing all of the waste. And what happens is that the paper fiber pulps up and the food component cooks down into the liquid phase. What comes out of the JunoClave looks a little bit like brown porridge with a lot of recyclables in it. And this is where we start the proprietary separation process, where we first extract the fiber component and the food component. And what's left are the larger pieces of materials that we then take to traditional MRF-like systems, where we then sort out some of these recyclables. So for example, we'll use eddy currents for non-ferrous materials such as aluminum. We'll use magnets for ferrous materials. And the fiber component, we clean it and in multiple stages to the point where we can then run it across our paper machines in Toledo, and we make containerboard out of it, liner and medium. We then ship that to internal and external box plants. And this one happens to be our own box plant in Olympia in Washington. And at this plant, we can then make packaging products, such as for e-commerce, or even for food contact applications, such as pizza boxes. The other piece is a little bit more on the fiber component. And we handed out some samples around the room here if you want to take a look at it. There's a barcode on the back. And we just received a third-party certification for a chain of custody for this Juno fiber. So we are tracking the fiber component from the waste through the Juno process, through the paper making process, and through the box plant process. And this allows us to offer this Juno fiber certified product. And we would offer that to customers who are really interested in landfill diversion and who are looking for a unique fiber that doesn't exist on the market today. So how do we fit into the waste hierarchy? We do not impact the top half of the triangle. We don't impact the reduce, reuse, recycling process, and that's generally source-separated materials. What we do impact is the bottom half that goes mostly to landfills, and typically that is more than 50%. So what we do is intercept landfill-bound materials, we'll process it, and will then divert, recover up to about 90%. So the carbon footprint is always a question that we get. So we did a high-level analysis of what it looks like for a Juno process. And we are using the EPA WAR model and comparing with the landfill. And this is for 1 ton of waste. So on the left side, you can see there's a little bit of an energy input. So we use some power. We have to generate steam for the JunoClave. And there's also a little bit of transportation to bring the waste into our facility. And then you start the recovery process. And there's a big reduction you can see for the paper component. And then you have the food component, where you essentially prevent methane generation in landfills. And there's a little bit of a metal positive component, ending up giving us about net -1. And what that really means is that for every ton of waste that we process through Juno, that is equivalent to 1 ton carbon dioxide equivalent reduction in the atmosphere. So what does that mean? So in Toledo, our plant has a capacity of 70,000 tons. And so essentially 70,000 tons of carbon dioxide, right? So that is equivalent to the carbon sequestered by 80,000 acres of forest land every year. And that happens to be the same size as the city of Las Vegas. We also took a look at the impact on the city where we operate. And so before Juno started up, the city had a landfill diversion rate of 23%. Once we got up and running, that increased by almost 3 times, up to about 66%. Now, 66% is one of the highest, if not the highest, diversion rate in Oregon. And in Toledo, we are not sorting out plastics and some other difficult materials. So this rate will go even higher at our next installation, where we're also going to include some of these more difficult materials to recycle. So finally, we work with cities, and we work especially hard with the people that live in these communities, because it has to be a good fit for this type of technology. And the local hauler in Toledo is Dahl Disposal. We have a great partnership with them. And what they've been able to do is not just give us the waste from Toledo, they are now also pulling in waste from all of these local communities around Toledo, like Newport, Lincoln County, and so forth. So finally, if you're looking to divert waste from landfills and you're looking for a high diversion rate up to 90%, please come see us.
Thank you very much. And moving on, we'll have Sean.
Hello, everyone. Thank you for joining. I'm honored to be here. Some great guys, and share with you today an expression of our technology. As you can see up here, Waste2H takes that fantasy to a reality with our technology and how we process. And what you're seeing here is a little bit of a depiction of what that fantasy is. And as I walk you through our presentation today, you'll get an idea of how we are making this a little bit more of a reality. So first thing, our company, Waste2H, is a partnership. It's based out of Long Beach area, Los Angeles, and a partnership with Japanese Blue Energy Company, a Japanese technology developer. They're the ones who developed the system. What Waste2H does is handle the engineering and the sales side of things on technology like this. And so what we will do is we'll look for partners and an opportunity to bring a system in. What we'll do then is help get it set up, construction, engineering. As we work through details of it, start getting it operational, we're then going to pass those operations on to our partners there. We will then continue along with remote monitoring, as well as some sort of a maintenance agreement going forward, just to continue to make sure that the technology is operating appropriately. So as I said, our company is relatively new, but the technology is not. It's been in development for over 16 years. So we're on our 4th generation right now. This is a picture of one of our 4th generation systems in Japan. Our target is 2 types of systems. One being a smaller 1-ton-a-day mobile unit that's going to be transportable. The other option is the stationary. We're targeting, our sweet spot is about a 24-ton-a-day system that's processing 24 tons of waste per day. And so on average, as we're pulling that hydrogen out, with 1 ton of feedstock, you're getting approximately 50 kilograms of hydrogen, which then can be used for fuel or it can be used for power. So let's talk about feedstock. That's always the big question, especially in these types of environments here. So what type of feedstock can we take? We can take all sorts of forms of municipal solid waste. Because our system is a decentralized and distributed system, it can take all different types of forms. And we have a lot of flexibility on the quality variation or contamination, as people say. So we can take plastics, we can take low density film plastics, we can take sludge, all forms of sludge. We take municipal solid waste, we can also take organics. As you see how our system works, you'll start getting a better idea and understanding of how those variations can play and how our self-regulating system is going to adjust based on what that quality variation is. So one of these pictures up here is our low-density plastic film. This is one of our upcoming commercial projects. We're looking at 2 stationary systems we're going to be putting on the island of Martinique in collaboration with Velcom, which is an ecological energy provider out on the island of Martinique. Now, the island of Martinique they're a big export being bananas, and they use these single-use low-density film plastics. So what we're going to do is work with them in bringing a waste-to-H system out there. They can take all those single-use plastics, put them through the system, turn it into hydrogen, again, to be used as fuel or possibly for power, depending on what their needs are. But this is going to help that island now avoid having to export all of their waste out to France somewhere thousands of miles away. So this is one of the solutions that we look at in partnering with, whether it's remote locations or different companies, is how can we try to minimize some of those excessive costs that come on the back end of this as well. So we take all those feedstock, we process it through our system, and again, now we have clean, green hydrogen, clean energy production, and hydrogen gas. So what is our system? So we have an indirect heat that heats these little ceramic balls, our heat carriers. And these heat carriers drop into our convection cracker and create a gasification process. So when we have our feedstock come in, just like some of these other technologies, we have first a step where we need to shred some of that feedstock, get it down to a manageable size so that our gasification process is going to be effective and maximize our yield. So as the feedstock comes in, we have our combustor that's heating our heat carriers. Our heat carriers are dropped into the convection chamber. That gasification process happens. Out of that, you're going to get a syngas that's very rich in hydrogen, about 50%. That's going to go into the reformer. Now, any of the char that's remaining in the convection cracker, it's just going to go back down to our combustor, keep heating up our heat carriers. So we have a cyclical process, self-sufficient, self-balancing. Now that hydrogen that comes out into our reformer, we're going to have some partial oxidation. We're going to extract that hydrogen. We now have our clean hydrogen, and any remaining CO2 or CO goes back into the combustor. Now our system was already going to be a carbon neutral status, but now we just recently partnered with a new technology called Captico 2. So we are also now going to capture any of those CO2 emissions that were already very low coming out of our flue gas. We're also now going to capture that's going to bring us to carbon negative as well. And that can then be, once it's captured, it's going to be sold as limestone or something like that. So as I mentioned, self-balancing system. So say you start getting some increased temperature inside of our combustion cracker, well, that's just going to create some more gas, less char goes into our combustor. Now the heat transfer going to our heat carriers is going to be a little bit lower. That means when it comes into our convection cracker, well, it's naturally going to lower that temperature. So vice versa, same thing. You have decreased temperature inside of our our cracker. Well, now it's all going to self-balance. So that's where that variation on our feedstock comes into play. And that system, say you start getting some new variation coming in, well, we can make those adjustments, and the system just does that naturally on its own. So this is our standard configuration. We're going to be looking at what sort of a waste is going to come in, whether it's MSW or another particular feedstock. If we're looking at our stationary 24 tons a day, we're putting that into our production. We're producing about 1,440 kilograms of hydrogen. Now we're looking at how do you want to input this. So this is where we start working with our partners and identifying, it's not always just going to be one entity. We might have one company says, look, we know everything about waste, but we didn't know what to do with the hydrogen. Well, we have another company, maybe a port, an airport, something like that says, look, we just get rid of our waste, but we need hydrogen. Whether it's to fuel our long-haul trucks that are coming through the port, or whether we need power, we will buy the power. And we've had these types of conversations. And so now we start looking at what are these marriages that we can bring together, these partnerships. And so if we have a waste company that we can start working with, where we start diverting some forms of their feedstock into our system, we can then have partners on the other side that say, we will either send all of our fueling trucks there, or we can put that directly into some sort of a solid oxide fuel cell and just generate power. And now we have somebody who's already committed to purchase that power from us. So that's where we work with our customers in figuring out what the right, formula is going to be. So let's talk about the CO2. Obviously, that's a big question. So if we're processing 24 tons of feedstock a day, estimate about half of that is going to be carbon in some form or another. Estimate reaches about 44 tons of CO2 per day. That's 15,000 tons a year. A standard gas station is going to be fueling about 300 vehicles per day. And so if we can take 3,000 vehicles off of the road using our process and eliminating those CO2 emissions, that's going to help us reach our goals of zero emissions. We also look at, we still have that hydrogen we're producing. So not only are we taking that CO2 out of the environment in our process just naturally, which means we're taking about, with 300 cars fueling a day, estimate they fuel every 10 days, that's 3,000 vehicles. So we're taking those off the road. At the same time, our process, if I go back here, with our process for generating our hydrogen, producing it, we put that into a fueling station, a dispenser of some sort. We're almost fueling nearly 300 cars a day as well. So that's where we start looking at this process with the waste-to-H system and how we can not only take vehicles off the road and eliminate some of those CO2 emissions, we can also put more vehicles back on the road because our system is now generating that hydrogen that can be used as fuel. So a couple different markets that we target. As I mentioned, we have our 24-ton-a-day system, so that can be in certain areas where we had a little more space, but we also can look at remote communities where we bring that waste, that's waste-to-H system up there. They're generating their waste already, like for example, the island of Martinique. If we can help them avoid exporting that waste out to a landfill somewhere and divert that to a waste-to-H system, we can, again, generate power, generate fuel. We've also talked about the ability of our disaster relief program with a 1-ton-a-day mobile unit. You have a tornado rip through some town in the Midwest. What if we can bring a mobile unit to that town? They have a waste that they need to clear and get rid of. At the same time, they need power. We can put that hydrogen coming out of the waste-to-H system directly into a temporary generator with a fuel cell. So there's a lot of different approaches. We're excited. We're in talks right now with Waste Management on a potential pilot project in the Bay Area that would be achieving some of our goals. Once we show the proof of concept with this, how our technology is already operating, a 1-ton-a-day system in Japan right now. We have another 1-ton-a-day program that's going to be starting up in Claremont, California, sometime this year. So once we show that proof of concept, again, we already have some of these partners in place that are interested in either purchasing the hydrogen, directing their vehicles over that way, or purchasing the power. That's it. If you have any questions, please feel free to come up afterwards. Thank you.
Thanks, Sean. Moving right along, we're keeping on good time right now, so we're going to have plenty of time for Q&A. We'll have Bill come up with Cyclyx. Thanks.
Home run, Sean, home run.
So quick comment before I get started. You heard Sean mention that their company's been around for 14 years. Cyclyx is a joint venture, but one of our parents, Agilyx, has been around for 18 years working on these conversion technologies. And they take time. So fantasy versus reality, we're now at the point where commercialization is starting. And these technologies that have been under development for years, trying to find solutions, are now being commercialized. I mentioned Cyclyx is an Agilyx company. Agilyx has been around for 18 years, focused on pyrolysis of plastics, mixed plastics, as well as discrete plastic streams, polystyrene, PMMA or acrylic as well. Agilyx has two subsidiaries, one Regenix with America's Styrenics. It's a 10-ton per day facility taking polystyrene back to a styrene monomer in Portland, Oregon. And the other is Cyclyx, which is a joint venture with ExxonMobil, focused on aggregating plastic feedstocks for advanced as well as mechanical recycling. As we thought about how to approach aggregating feedstocks, there are a number of challenges that plastics are facing today in terms of getting to larger scales. we've been capped out at 10%. There are recent articles coming out that say in the United States that's actually dropping as we've stopped exporting material to other companies. So how do you change that? How do you turn it around? How do you start that moving upwards? Ideally, we hope towards 90% in the long term. There are challenges. One is the chemical complexity of plastics. If you take this apple juice bottle, the bottle's PET, the top's something else, the label has other inks, dyes, maybe a different type of plastic. That's compounded as you look at the different types of plastics. You start adding fillers and dyes, you start adding fire retardants, multi-layer films, oxygen barriers, those types of things. It becomes very complex very quickly given the diversity of waste plastics, both commercial, industrial, as well as post-consumer plastics. And you throw on top of that the contamination, use-related contamination. How do you deal with the leftover food? How do you deal with maybe chemicals left in a plastic bottle? So say you get over all of that. Then you have supply chain challenges. The current supply chains for plastics are focused on aggregating what can be recycled today mechanically, the PET bottle, HDPE drug. But the supply chains aren't set up to take all plastics, to separate plastics, take plastics, and deliver them to these new emerging technologies. Even if the supply chains were there, the existing infrastructure isn't there. The majority of MRFs are focused on what can be taken in and sold into a mechanical recycling market. So the multi-layer films, the complex plastics, the things that are difficult to sort out are not included in that. So you need the infrastructure to do that. And then on top of that, advanced recycling has new demands. They look at it as a chemical. They're not looking at it as a plastic type. So what else is in there? Your chlorides, your brominated fire retardants, how much sulfur is there, how much nitrogen is there, all that impacts the oil and how they can use that in a circular pathway to create more plastics. So Cyclyx is looking at this from a different point of view, taking a new approach to plastic recycling. We have a front end, which is our 10 to 90 initiatives, focused on what is a very ambitious goal of increasing both the recyclability as well as recycling rates of plastic from 10 to 90%. I say recyclability because we need to find ways to qualify plastics for these processes as well, to make the plastics recyclable in order to increase those recycling rates. Cyclyx itself is more focused on chemical characterization and preparation of those feedstocks. So looking at feedstock streams, understanding what the chemical profile is to bridge the waste industry with the chemical industry. Let the chemical industry feel comfortable because they know the chemical profile of those waste streams. Our focus is targeting all plastics. We want to lower the challenges that consumers as well as companies face in participating in recycling. Don't tell them, yeah, we want this, but you need to take the label off and you need to take the top off, and don't smash it because then it's a problem as well. And there are other things that look like this, but we only want this one. We're focused on taking all plastics and working with municipalities, commercial, industrial, and other partners to do that. Deploying new strategies for taking back material, whether that's through retail, through schools, through municipalities, direct with consumer and drop-off, processing them, looking at them chemically, developing facilities that can take all plastics. We're developing our first facility now down in the Houston area to support Exxon's Baytown operations in recycling plastics. That'll be designed to take all plastics in all forms, films and foams as well as rigids. Simplify participation, increase those recycling rates. Again, supporting both mechanical and advanced. In taking all plastics, we believe we will get a lot of plastic that is suitable for mechanical recycling. Pull that out, put it into mechanical recycling. Use the balance, the waste that is going to the landfill today, that plastic, to supply feedstocks to these new emerging technologies. So a little more on 10 to 90 and Cyclyx. 10 to 90 is focused across the board on encouraging consumer participation as well as commercial and industrial. But a lot of that is education and consumer engagement. Reach out, let them know what's possible in their communities. Provide incentives. Incentives are key. A lot of people have an incentive to recycle because it's the right thing to do, but how do you reach out and get everyone to change their behavior? Starting at a young age is a great way to do it through schools and through education. Also provide incentives, work with partners who have a vested interest in the supply chain, the value chain of plastics, to sponsor incentives to get people to participate in those consumer take-back programs or the commercial take-back programs. Once that material is aggregated and we have it flowing, understand it from a chemical profile standpoint. Look at designing custom facilities. We are demand-focused. We are not supply-focused. We're not going out and aggregating material and then trying to sell it. We're working with our partners who need the material, putting together dedicated supply chains and designing custom facilities for them to prepare the feedstock that they need. And that's both from a chemical profile as well as from a physical profile. What size do they need? Is it a 1/4 inch minus shred? Do they want pelletized material? Can it be 2 inch minus? So what we're delivering is prepared feedstock that's ready to go into these processes. Let the technology companies focus on running the facilities, and we'll focus on aggregating the feedstock for them. And in doing so, you create circular pathways. You increase the ability to recycle plastics, increase the recyclability of plastics, increase the corresponding recycling rates. You can create these circular pathways for plastics using mass balance approach, tracking the custody. We're ISCC Plus certified. We can track custody throughout aggregation, all the way through delivery of feedstock, whether it's post-consumer, post-industrial. Prepare that to meet their specifications and put it back into recycling. Now this will be mechanical, circular polymers through advanced, and then there's, if you look at the spectrum of fuels, of plastics, some of it may not be suitable for direct plastic to plastic. There will be opportunities to increase the use of plastic going back to fuels. All of those products are lower carbon than the equivalent virgin production, between 40 and 70%, depending on what LCA you look at. So it is beneficial to utilize these pathways. It's beneficial to recycle plastic. It doesn't compete with reduce and reuse, but once it is used, recycle it. So our members, I mentioned we were focused on supplying first, demand-based. And you'll see a lot of the large petrochems up there, Exxon obviously, but Braschem, LyondellBasell, Dow, Chevron, Phillips, Sabic, Nova. On the polystyrene side, Amsty and Ineos Styrolution. We are supplying feedstock today. We're supplying it into these circular pathways and beginning to build out the rest of the plastics value chain. We have Sunoco and Casella Waste, two of the early companies who've joined us to help increase the plastic they can take in, and we can find a home for it. And we're beginning to get consumer products companies, and Velcro, Suncast, ADS, Reynolds, Corning, all looking at finding ways to take back the products that they're putting out into the market. So happy to answer additional questions. We're really excited about this. We see one of the biggest impediments to advanced recycling and mechanical recycling and increasing those rates is the feedstock. We're qualifying the feedstock and building dedicated assets to supply our customers with feedstock. So happy to answer any questions. Thanks for coming out and listening.
Thanks again, Bill. Great presentation. Next, we have Steve, going to join us from GBB.
So good morning. I got the technical part. I'm Steve Simmons with the consulting firm GBB. We are a solid waste advisory firm. I'm going to talk today not so much about a specific technology, but more of a process. My target out there is the executive director of a DPW, Department of Public Works, that's wanting to say, how do we implement a project like this? You know, I've got great interest, but boy, it's big and it's complex. And I'm going to talk today using a case study of a project that we're doing with Kent County, Michigan, and their Sustainable Business Park. So let's see. Okay, yeah, here we are. Okay, so what is the Kent County Sustainable Business Park? It's an integrated material recovery and manufacturing complex. It's been established by the DPW, which has the statutory authority for managing municipal solid waste in Kent County. It's going to be built on a 250-acre site that they've already acquired for a landfill, a future landfill, but they'd rather not build a landfill on that site. We have a project development agreement in place with a joint venture between Energia and Continuous Materials, and we expect to break ground in early 2025. So how did this project come about and what are some of the reasons? Quickly, briefly about Kent County, Michigan. It's the economic hub of Western Michigan. It's home to the city of Grand Rapids, if you would know what that is. Second largest city in Michigan. It's got an agriculture and manufacturing economy and generates about 625,000 tons a year of waste. The Department of Public Works manages it. They've got a single stream MRF, got a 600 ton a day waste energy plant, 1,000 ton a day landfill, some transfer stations, some auxiliary citizens amenities. And those of you who have some gray hair and have been around maybe like I have, in the 1990s, we would have described this as an integrated solid waste management system. That was the newest buzz term in the 1990s, right? What has led the county to thinking about this project? Well, the landfill's filling up. It's got less than 10 years of life left. The waste energy plant's 30 years old. It's worked great for 30 years, but it is a 30-year-old plant. There's plans to make a new round of reinvestment in it and extend the life for another 20 years, but you know, it's undersized for the county's needs now. They got a MRF, but it's 15 years old. It's an old style MRF with a lot of manual labor. It doesn't have the automated equipment. Waste has continued to grow at 2.3% a year for the last decade. The recycling rates haven't kept up. Maybe a 17% recycling rate in the county. And that has led the county to say, let's reimagine what we're doing. And so we came up, there we go, with the Sustainable Business Park concept. The DPW went through a policy process of let's adopt the policy and let's try to divert 90% of the waste that's going into our landfill. They engaged with the consulting team, we were selected, and came up with a master plan for developing this project. Single stream MRF still, but a plan of what can we do on these acres. Ultimately, the plan was adopted by the DPW's board, and it led to a request for a procurement for an anchor tenant. We decided to model this as we've got a business park. You got a business park, what is one of the first things you go and you look for? You look for an anchor tenant. You look for someone who can put that facility in to receive the waste, to separate it out into the individual piles. You know, where our technology is great. We can separate trash into 20 or 30 piles if we want of materials, but then what are you going to do it? As it was said earlier here, you know, it's a lot about logistics, but it's also a lot about markets, right? It doesn't do any good just to sort it out into individual piles. So the procurement process started in June of 2020, right after the pandemic. We issued the request for proposals, got proposals in September, 7 responses, did an extensive review. A year later, we're finally ready to narrow it down to one, and a recommendation was made to go with the Continuous Energia joint venture. And finally, after another rounds of negotiations with the county, talking to the policy leaders, in March of this year, we signed a project development agreement to move forward with the project. So we're off to the races now. So what are the next steps in developing this project and the steps that you can replicate over and over? Well, we're ready for a 30% design phase. That's what we're doing now. With that design package, we'll go to permitting and regulatory approvals. We've got to negotiate feedstock supply agreements, The county has a flow control ordinance for part of the county, but not all of the county. That's got to be adopted and modified and put across the whole of the county. And then we'll need the independent consultant reports to do the feasibility studies to support $240 million worth of bond and equity financings. These are big, complex projects. Next steps, and then hopefully we lead that to a groundbreaking in 2025. Went through that quickly, but to get to this part, what's the keys for success in developing a waste conversion project? How do you get there? What are the important parts? And when I look at this project, I see several keys and takeaways, and I'd love to discuss this later with you, but a visionary leadership at the public sector, at the lead of the public agency. Darboz, the executive director of the Public Works, has a vision, and he has the will and the personality to try to push that far, but he's got a very great staff supporting him on that. And so it takes that, you've got to have a strong public agency that's implementing this. These things don't just happen. Got to acknowledge, and we did this right from the very beginning, it's going to cost more. It's going to cost more than putting into a landfill. If you think this is going to be cheaper than the landfill, then just stop right now and save yourself the project development money. It's going to cost more. How much more is the issue, and will the constituency agree to pay more for that? We did some studies on this early on in doing surveys, and the general public knowing very little about the project other than we could get to 65% diversion rate, and that would keep them from needing to do a new landfill. And we said, would you pay $5 a month more for that? And that was an 80% approval rating. Yeah, I'd gladly give up a latte a month to do that. That's about what this will cost. This will cost less than $5 a month per household. So, you got to get the extra cost down into a level that the average person can understand and relate into their home, their budget. You need a multidisciplinary project development team. Again, we're the technical and kind of business consultants to the county, but there's a local engineering development team, there's a permitting team, there's a communications team, a finance team. It takes a broad team with multiple disciplines to be able to push this thing through to the finish line. We had an extensive public outreach and communication from the very beginning, all the way back into the master plan. And even though we thought at the time it was very extensive, we had multiple community stakeholder meetings. We get up now and we're talking to people and they scratch their heads because they've never heard of it. This is something new. We've never heard of this project before. So you can't not over communicate. And then another one, which is very important when you get ready to do these things, is public control of a suitable site. If you select a private sector developer, and eventually, these technologies are private sector, so there will be a private sector party in here. You need to have the site for them. If you force them to go out and find the site in the community, it just won't happen. The public sector's got to step forward and put together the site. That's my part, and I'll be happy to answer questions afterwards.
Thanks again, Steve. Next up, we'll have Tex to join us. You can see, I think from their title there, they say it's not a fantasy, it's a reality.
When you live in Texas, nobody calls you Tex. But you come out here to California, which is where I'm now living, get into the renewable fuel business with a partner named JD, everybody wants to call you Tex. I like that because everybody remembers the name Tex. Nobody remembers the name Tom. So out here, I'm Tex. JD and I got into the renewable fuels sales distribution business several years ago, and we're successful at that. We purchase, transport, sell millions of gallons of renewable fuels every month. Looking around at an expansion area, we moved into the production of renewable fuels. The production of renewable fuels, a lot of companies, the big players, they're looking at biomass such as corn oil and soybean oil as their biomass to use to produce renewable energy. That means that the price of soybean oil is just doing nothing but going up, up, and up. We looked around, we saw waste biomass as the logical direction to go. So we got into the waste business, which is where we are now. Looking around at that, boy, there's a lot of waste out there. There's an estimated 35 million tons of waste disposed into California's landfills. We're in California. We're located in Bakersfield. Bakersfield is a center of the agricultural valley of California. So not only is there a lot of waste, there's a lot of agricultural corporate giants out there. So we're in the agricultural side as well as the waste side. And looking at the biomass, we're working with a couple of municipalities and taking their waste into production of both renewable energies and in composting. Composting is a logical area to go into. We love that. Diverting, repurposing, and the outtake of the renewable energy is synthetic gas. So we're moving into the landfill, working with the landfill departments to produce synthetic gas. Synthetic gas can be repurposed in any of several different directions: hydrogen, renewable diesel, renewable energy, all sorts of areas with that. So our purpose is to bring the proper technologies into a public-private relationship with the municipalities, pick out the right technologies, and there's some great technologies here on this table, but boy, there's a lot of frogs out there. One of our purposes is to go out there and kiss the frogs and find the princesses for the municipalities to be working with. We've got the offtake. We're selling the renewable diesels. We're selling the renewable energies right now. So we've got the offtakes. We've got the biomass, which is the waste, and looking for the right technologies. That's our job right there, is working with a public-private partnership with the municipalities. And that's where we excel, and that's our focus right there. These are just diagrams of some of the different technologies that you've seen already here. And believe me, some of them are great, some of them really work. Some of them, as I say, are frogs. When y'all are out there looking for the technologies, be aware that there's a lot of companies out there that are saying, we're real, we're real. You look at their website, and their websites sure look like they're real, but when you get right down into it, they're saying, yeah, we can get it off the drafting table for $85 million. We'll turn our frog into a princess. Some of these municipalities don't need to spend $85 million on technology that's still on a drafting table when there's real technologies out here that you can be working with today. That would be my best advice for reality or fantasy. Yeah, there is realities out there, but boy, there's a lot of fantasies out there also. So just keep your eyes open as to who you're wanting to work with and who you're working with. If you're looking for a specialist to help guide you in some of that direction, we've got some specialists up here. We're one of them, but we can work with the municipalities to do a public-private partnership. We've got the offtakes already in place, and we're looking forward to that, working with any of y'all that we can move forward with. Thank you.
Thanks, Tex. Or Tom. I remembered. So this is the part where hopefully y'all can make this a little bit more. They make the job easy for me. We'd love to have some Q&A. You know, it's an interesting topic that we've gotten into. You know, fantasy or reality. We're all familiar with systems that have been put out there and the challenges that they've had. Feedstock is a big challenge. You know, us as a manufacturer of what we do, aside from the equipment side, you always want to know what is the input material. What are the contamination levels? What can we deliver to the systems? I'd start by asking Carlos, what do you feel the biggest challenges are to make the fantasies, in some cases, become the realities? Any of you want to take it? Not specific.
I mean,
And sure, audience interaction will be great too.
I'll start. I would say, I think one of the biggest challenges is just generally buy-in. I mean, for a lot of what some of you guys were talking about up there, it's just getting the buy-in, Steve, to your point, having that, public sector, those leaders who actually step up. And, we certainly are seeing, I would say, more and more opportunity, for grants, public funding, things along those lines. But you really you need those champions who are really going to step up and continue. We're talking about the same thing. We had technology that's been in process for 16, 17 years. It takes time. We're definitely getting to that point where we're ready for that next step. It just continues to be the people who are going to take that chance and step out of the box that they've been in and look for that opportunity.
Yeah, I think that's a good answer. And I would also say that permitting it's a big challenge. And if I was asking everybody in this room if they think permitting is getting easier or more difficult, I'm pretty sure what you're going to answer. And so when we permitted this Juno plant in Toledo, we had a big outreach plan ahead of that. We talked to all of the communities around Toledo, not just the cities, the city's staff itself, but also like the people. We had a lot of these meetings all over the place. And when we finally got the permitting, it took less than 12 months. And that's incredible. Oregon isn't the easiest place to get anything done, right? So I think when it comes to these technologies, I think they have to fit within wherever they're supposed to go, whatever community they got to fit in. And as you guys know, waste energy, it can take 4 to 8 years to permit. And I think for us to come up with something that's better than waste energy, it got to be something that you can permit in a reasonable time.
I believe that municipalities have got a problem right now. They don't have 2 years to wait. They don't have 4 years to wait. They've got to find that solution right now because they've got waste coming in and they can't put it into the landfills anymore, at least in California. They can't be just dumping it into their landfills anymore. They've got to find a solution, and that solution needs to be something that can be implemented sooner rather than in 3 or 4 years. And that's a frustrating thing because sure, you've got to vet the technologies, you've got to go through the permitting process, but you've got a problem right now with landfill waste stacking up. I'm seeing that over and over in municipalities that we're discussing this same problem with every day. And we're saying what we can do right now is sure, we can start composting. And we have a large composting division that we saw a lot of upgraded composting to the commercial farming sector because we are in a commercial farming sector of the country. But it is a frustrating challenge to have the permitting and the cost be a stumbling block for making inroads to a problem that we have right now. We see that over and over, and I encourage you to look at the new technologies, even though I'm trashing them by being on the drafting board still. But some of them are real, and some of them are quite good, and some of them are a little bit more modular than these great big factories that we're used to seeing. And they can do something with the waste right now on a skid mounted on almost a portable modular unit that's scalable and buildable. I'd suggest that you start out with scalable systems that can grow and expand, and a lot of these systems are exactly that, and I love them. So that's where I'm taking this.
Real quick, if I could add something to that, because Tex, you brought it up a couple times, and I think it's important. I don't know if everybody's aware, but in 2020, I believe it was, NWRA and SWANA worked together, and they put out a couple of documents that helped going through the validity, the fantasy versus reality. I've got those links if you want them, but they're unsolicited proposals and responses is one of the documents that they put together, and emerging technology checklists, so that you can go through and validate the technologies that you're looking at.
I'd add just two things to these comments. One, Tex touched on this a little bit, looking at fantasy or reality, but keep an open mind. you can find an article that slams any emerging technology, especially when it comes to plastic recycling. There are so many articles out there that is just all bad. Keep an open mind. And secondly, in order to affect true change, you need participation of the whole value chain. It's not just the resin producers. You guys have to do this. It's not just the conversion technologies, but it's the converters, the CPG companies, the distribution, the retail, the aggregation on the back end of waste and recycling companies, and the consumer, for sure. And that value chain needs to step up. Steve mentioned offtake. Offtake is great, but if a company says, yeah, if you make it, we'll take it, and that's the end of the support, there needs to be more support, more engagement. Help this industry grow by participating in it.
That's true. I mean, what's the hard part about this business? Everything. I mean, there's just no easy part. It's the trash business. Technology development is difficult. For a while in my career, I worked for a plasma gasification firm that managed to raise and spend $250 million. Got nothing out of it. That's hard. But, you know, that's the magnitude of the technology development of it. But the contracting, the financing is all. But I think feedstocks and offtakes are some of the most challenging so far. Hopefully, we're seeing signs change that to Bill. You know, the consumer products companies coming through now and finally putting their money where their mouth is. That yeah, we're really committed to recycled resin. I hope that's true.
Great. By the way, there is a microphone in the middle if anybody else has any questions. One of the things I was going to ask is, you know, Bill, maybe this is great for you and anybody else can jump in, but you see in the potential of the feedstock and bringing in the material, do you find resistance at the MRF level? Because, you know, from an educational aspect, you're potentially what a lot of MRFs would consider contaminating the input materials. Is that a challenge you run into?
So yes, we run into that challenge. The infrastructure today is built to handle specific things. It's the bottles and the jugs. Beginning to handle films, specific films that are fairly easy to identify. So it's not, I wouldn't say it's a challenge with the MRF, it's a challenge with the design of the MRF. And it's a challenge as we look to expand to all plastics, you're aggregating plastics where there really isn't a market for them. And MRFs are private enterprises, right? They're there to maximize profit. So to your point, if you have a stream that's much higher in contamination, that's cost to them. It's operating cost and it's disposal cost. So there are challenges there, but we're working through them. We're working with the City of Houston, with Exxon, LyondellBasell, and FCC Environmental, and they're being very open about how do we do this within the confines of our business model, but how do we work together to expand, in this case, plastic recycling, but also increase the fiber and the metals as well.
Okay. Anybody else have any input? Great. Question from the audience. The seal has been broken.
Yes, I believe this is on. Hi, Riikka Yliloma, working for Climate Strategies Lab. Wanted to ask, well, we have all of you here. We all captured now that this is complicated, supply chain change is required. What are the key policies, whether it's state or federal level, or is it another kind of strategy that we could enhance this change and implementation of these future technologies?
Seems like it's in your wheelhouse.
Well, certainly there are policies which could be adapted to do that. You know, there's renewable energy credits on the electricity. There's renewable RINs on fuel and energy. There's not a lot of credits or anything on additional recovery of materials. So something to help subsidize that, because as I said earlier, it's going to cost more than putting it into a landfill. The issue is always how much more and how does that extra cost get covered? So those could be policies at a specific county level. They can adopt policies, as I was talking about Kent County expanding their flow control district. And, then you can somewhat moderate the cost impact. It's still going to go up, but you can still get the feedstock. If you're going to attract private equity to come in and build a facility, and they're going to build a $200 million facility in the ground in that county, they're only going to do that if someone can guarantee that the waste is going to show up. Because you can't just pick that facility up and move it to another county. It's there. So policies like that, those are sometimes tough locally to enact. One thing you learn quickly here, every ton of trash today is picked up in America. It's managed, usually by someone making money on it. And if you want to do something new, you've got to take it away from them. So there's always that inherent conflict also, right?
I'm coming to this from the private sector. I'm CFO, MBA, CPA for my companies, and my mantra is cost, cost, cost. And I'm also hearing that same mantra from the public side. A lot of them are saying, I don't have $100 million to implement someplace to stick our trash, nor do we have the ability to charge our residents X number of dollars a month additional just to stuff their trash somewhere that's renewable. Find me a cheap solution and find it now, because we got a gun to our head. And that's the whole issue right there. Again, I'll point over to some of the newer technologies that are boutique in size, that are skid-mounted, portable, modular, scalable, and that's where I'm looking, and that's where I'm kissing a lot of frogs. A lot of those technologies are not real. Some of them are showing to be real, though, just like these technologies are showing to be real, and they're getting smaller and smaller and smaller, and that means they're more affordable and more affordable as we move forward. The other point is that we've got multiple streams coming in from tires to sludge waste to just raw sewage and organics, tree trimmings. We've got to be adaptable to have either one-stop shopping for the technology, or have that technology allow different pathways into that technology so that you can turn on a dime and produce from different types of waste streams what you need to come out the other end. Coming out the other end also needs to be a movable target, whether you're producing hydrogen or a renewable energy. I'd like to see some technologies that can pop out synthetic gas out of one end that can in turn be moved into different technologies according to what the market is demanding, to maximize the profit for both that private sector and the municipalities. And if you're a municipality, don't just hand it out to a private sector to make all the money. Demand a profit share in there with them, because that's where your money's going to come from.
So just quickly, a great question. There's a lot of policy out there that's focused on restricting, whether it's, I'm focused on plastics more, but restricting polymer type to be used. It's restricting what can be classified as recycled content, whether it's post-consumer or post-commercial. Some qualify, some don't. In my view, our view, Cyclyx, the policy should not pick winners and losers. It shouldn't pick winners and losers in plastic. It should let competition happen so the plastic is used for the best source, the best application. It should also, if you think about EPR schemes, EPR schemes are fine, but let them be open to multiple players participating in that. Don't pick a single company to run a state or run a geography. So legislation can be very helpful. It just needs to encourage technology development, not suppress it.
And that's an interesting point too about encouraging competition, because the reality is, there are so many different types of technologies out there that are going to be productive. And, while, we can do a tour of a MRF facility and look at just the bales and bales of waste and say, well, can we have that? And, then you start getting into the incentive side of things. policies that are looking for incentives to encourage, certain types of diversions. And it's, well, no, you can't touch that bale of plastic because I sell that. I make a lot of money from it. Okay. Well, we'll take everything that falls on the floor then, So you try to find that balance. You're going to have different waste streams and feedstocks going in different places, but encourage that, that competition, because there might be one technology that's really going to maximize this type of feedstock in a specific way for you. And this technology might do it differently, but it's going to maximize a different type of feedstock in a different way. And encouraging, through the policies, some sort of incentives in some way to encourage not just the public getting behind it, but also the private sector.
Yeah, I think Steve said it right there in the beginning. To change where the waste flows go is really difficult, right? So in Toledo, because once it's ingrained, there's a system, people are making money, and so in Toledo, we had to fight for all these cities. We're turning over a city in our direction every month or two, right? So it's coming, but it's taking time. But you got to fight, and you got to fight like you're the third monkey on the ramp to Noah's Ark.
Thank you.
Looks like we got another from the audience.
Hi, I'm Taylor Williamson with West Central Sanitation. I have a question for Mr. Henriksen with the Juneau process. I was curious, the first section is that autoclave or the Junoclave, and I'm sure the pathogens get killed in there, but I was curious if you have any issues with either like heavy metals contamination or PFAS from the plastics getting melted in there that you've had to deal with, and if so, how do you go about that?
So now you're asking me for trade secrets.
Okay.
So I can tell you, but I'm gonna have to kill you after. I was just kidding. I got my attorney in the room, so I gotta be careful. Well, maybe I wasn't kidding. Anyhow, what I can tell you is that so we do. I mean, we are part of a large. I mean, it's our flagship containerboard plant on the West Coast. So we do a lot of testing for all of these contamination. And the results so far has been incredibly promising. And we are really, really happy with the results. We were worried before we built the plant, right? When I came and said, hey, we want to build this Juneau waste recycling plant. And the mill manager, he wasn't too excited about it initially, but like I said earlier, so far, everything has turned out really, really good.
Okay, thank you.
So another question that was out there, and I guess this could be for all the panelists, is there any specific regions or countries or areas that you think are more apt to the conversion technologies, and where might they be? And maybe also share with us areas that, it's going to be much more difficult, areas that need and areas that probably won't adopt. You want to start with that one, Chris?
Well, so I think I answered it earlier when I said that you had to find the areas where people truly value landfill diversion. Otherwise, it's not going to work. You're never going to get a plant built. And so I think that's key. And I said earlier that there's another 1.5 billion tons of waste coming on stream over the next 30 years, right? And so we are engineering our next plant. And that plant is going to be bigger. It's going to be 1,000 tons a day. It's going to be, so that's 300,000 tons a year. But if you apply that size plant towards the additional waste coming on stream, going to landfill, we would have to build 100 Juneau plants every year, right? And obviously that's impossible. Although if my boss was here, he would make that my next target. But so the point is, we need to have a lot of new technologies that are, in my mind, they got to be better than waste to energy. And I think that's going to be the needle-moving driver that we need.
I think California is the role model for renewable technologies. I think the rest of the country is kind of looking at California sometimes with a little humor as to how far we can go with our renewable desires. But bottom line, California really is implementing a lot of great strategies that several other states are beginning to pattern their own regulations and mandates after. Oregon, Washington, Arizona is beginning to follow suit. So as we move forward, keep your eye on where California is taking some of these requirements, mandates, regulations. So a few of us had the Senate Bill 1383, which is the California Senate bill, showing the requirements that are upcoming to restrict landfill waste. Start looking at that if you're in some states outside of California, regions away from the U.S., and use some of those mandates as where a lot of these other states are going to be going in what they're requiring. Get ahead of the curve on that, and you're ahead of the game with where you're taking your own technologies.
I would also add to, what we're finding in a lot of our conversations. I mentioned we're working on the island of Martinique. We're having discussions with other remote islands where, you talk about the landfills are filling up or they're just running out of space and they need to find other options. So that's certainly where we're having a lot of our conversations. But it's also just identifying and finding areas like in those states in particular that when you have that person who's going to be bold and say, we need to find a solution for this, and then you just, okay, well, maybe that's a waste, management type of company, or whether that's somebody, who's looking at, in our case, taking advantage of hydrogen to be used as fuel or power. For us, hydrogen fuel in hydrogen fuel cell vehicles is still, it's going to take a lot more time. You for those types of technologies, you almost need that Elon Musk to stand up and say, I'm going to make this a thing. And suddenly there's Teslas all over California, and charging stations everywhere. You need those people who are going to be bold and step out there. The reality for hydrogen is it's still going to take time for consumer vehicles, but you are getting, the public sector fleets, you're getting the long haul truckers looking at those conversions, and then also being able to take advantage of the power. So what we do is, look for those potential partners, and whether they are in those states or not, just find the need to get rid of the waste so they don't put it in a landfill, find the need for the power or the hydrogen, and let's start bringing those together. And it just happens a lot of those end up being on islands as well.
So, where, not seeing any of these gentlemen's pro formas, those are private, but, in taking proposals and looking at what is out there in the data, you see, I think on a lot of these conversion plants, a tipping fee requirement somewhere $60 to $80 a ton. That generally covers most of them. Interestingly, if you're in New England right now, tipping fees are 100 plus in New England. And yet, so why isn't there more development in New England? And, Massachusetts sending 6 million tons a year. So, that region sending 6 million tons a year via train to Ohio and points further west. So why isn't there more? I don't know, other than it's just really hard to develop projects where there's such population density. I'm sure everyone here needs, a minimum of 40 acres. Finding 40 acres that's not next to some sensitive receptor someplace in New England is almost impossible. So not to dismiss it to NIMBYism, but it's very difficult to site solid waste management facilities. So there should be a lot of development in New England. I know there's a lot of people trying to do so because the economics are compelling. Now, go to Michigan and $35 a ton landfills, and you start talking about a $70 option, it's a much harder sell.
Very good. We're starting to run low on time. Appreciate everybody joining, and thanks to all the panelists who've helped us. One thing I think Steve said earlier when we were sitting down that made the most sense to me is, fantasy or reality, is it really there? And who would have thought, 5 years ago, 6 years ago, that robots would be sorting through waste and going after valuable commodities? It's a great point. It's going to move further. Is it reality today? In most of these situations, yeah, absolutely.